So the electric field due to plane sheet at any point is E equal to sigma upon 2 epsilon naught. Now if you observe this expression is independent of small r, and this is very interesting. We all know that as we move away from a charge, then the value of electric field decreases. For point charge, we know that E proportional 1 upon small r square. For the previous case, that means field due to infinite line of charge, electric field inversely proportional 1 upon small r. But here the point is at a distance small r, but in the expression of electric field we just have E equal to sigma upon 2 epsilon naught. So this expression is independent of small r. It means as we move away from sheet, the electric field due to sheet will not decrease, it will remain the same. But remember, this happens only for charges lying very close to the sheet. Now why this happens? Just listen this carefully. When the point of observation is very close to the sheet, then the particular point will be under effect of charge just in front of that point. But as the distance increases, as you take point P away and away, then more and more charge of the sheet comes in the field of view of the point. So the charge increases. We all know that with distance electric field decreases, but with the charge, increase in charge, electric field increases. Now here what happened? Distance is increasing, but charge is also increasing. So the decrease in field due to increasing distance is cancelled by the increase in charge, is cancelled due to increase in charge. Above expression is independent of small r, that is, the electric field intensity is same for all points lying close to the sheet. The reason is that as we move away from sheet, this you have to remember, more and more charge comes in our field of view, and this offsets. Offsets means cancel. This offsets the decrease in field due to increasing distance. It is very important question. In exam you may get that why the field due to infinite sheet of charge is independent of the distance. So in that case you have to explain this particular portion. Now continuing. This time we are imagining two infinite parallel sheets. If you observe the diagram, I'll take a sheet 1 having positive charge, sheet 2 again having positive charge. Surface charge density on sheet 1 is sigma 1 and on 2 it is sigma 2. And if you observe, this is sigma 1 greater than sigma 2. That means we are imagining greater charge density on 1. Here we are interested in finding electric field intensities at point P dash, which are on the extreme right and extreme left, and at point P. Now here, how to get field at P dash? Just now we have calculated the electric field due to a sheet is E equal to sigma upon 2 epsilon naught. Keeping that in mind, first sheet will produce field at P dash, and it is denoted by vector E1 and direction is towards right. Why? Because if we imagine a test charge here, this one will repel this test charge towards right. Similarly, second sheet produce field at P dash, and the direction of field is also towards right. So we take it as E2. So for point P dash, the electric fields are in same direction, so we have to add the two fields. Similarly for point P dash, the electric field due to first sheet is towards left. We represent it by E1, and for due to second sheet, again it is towards left, and its direction is as shown. So from the diagram it is quite clear that for point like P dash, which are outside the two sheets, the electric fields are in same direction. So net field would be the sum of the two fields. But what happens if we take point P in between? For point P in between, the field due to first sheet is towards right. Why? Because if you keep a test charge, then first sheet will repel that charge towards right. Similarly, the field due to second sheet at P is towards left. So E2 is towards left. So for point P, the fields are in opposite direction. So net field would be the difference of the two fields. So for point P, the electric field is equal to the difference of the two fields. And for point P dash, the electric fields will be the sum of the two fields. Keeping in mind sigma 1 greater than sigma 2, so E1 will be greater than E2.